Hi, in this video I want to talk about proportionality, powers, and pizza. Oh, okay, pizza. Everyone loves pizza. So you have a deal that's given to you by your local pizzeria. The deal is for a 12-inch pizza, $10. But then you discover their 6-inch pizza is only $5. So why not just get two 6-inch pizzas? Isn't 12 inches twice 6 inches? Well, no. Of course, you know the difference is that really you shouldn't be measuring pizza by a diameter. You should be measuring it by area because area is going to make you full, not diameter. So in fact, you'll get many more than just two 6-inch pizzas out of the 12-inch pizza. So this is a better deal. Okay, I want to model this precisely, and we're going to use proportionality and power functions to do this. So you've got your measuring tape out, and you have a way of measuring area, and you come up with the following measurements for pizza. So here's my table. Here's the diameter for each. I have a 6-inch pizza, a 8-inch pizza, a 10-inch pizza, a 12-inch pizza, and I've measured the area of each of these very carefully, and I've come up with, for the diameter of the 6-inch pizza, if it's 6, then I get an area of 28.27 square inches. For an 8-inch pizza, it's 50.26. For a 12-inch pizza, it's 113.1 square inches, which of course is much larger than twice the 28.27, making it a better deal. So how do I model this situation? What do I mean by model? I'd like to find a relationship between the diameter and the area. So how can I do this? Well, the first hint is that the area is measured in square inches and the diameter is measured in inches. So it's like measuring apples and oranges. What I first want to do is convert the diameter into something that I can compare with something that's in square inches. So what do? I square it, and I get square inches. So I'm going to look at the diameter squared. The diameter squared is measured in square inches. Now, if I have diameter is 6, the diameter squared is 36. If I have diameter is 8, then the diameter squared is 64. If the diameter is 10, the diameter squared is 100, etc. So these are my diameter squareds, and now it's completely reasonable to compare area with diameter squared because they're both measured in square inches. How am I going to compare? I'm going to take the ratio. So into my calculator, I'm going to look at the ratio of the area divided by diameter squared. See if I see any relationship there. So that is, I'm going to take area to 28.27, divide by 36, plug it into my calculator, and I get something's 0.78527. I take an area 50.26 square inches divided by 64, and I get a number like 0.78531. Oops, look, they're very similar. Let's see if the pattern continues. Here's an area of 78.53 divided by 100. I get 0.78530. And for an area of 113, I divide that by 144. I take the ratio. The ratio is going to be 0.78542 according to my calculator. So look at these numbers. They're very, very similar. And what this says is it says that area divided by diameter squared is constant. Okay, it's about 78527 or 78553. Okay, so all these numbers are so close. So area over diameter squared is constant, or essentially constant. I maybe made a small error in my measurements, but it looks like these numbers are almost the same. It's constant. And in this case, we say that area is proportional to the square of the diameter. Okay, so anytime you have two quantities, here I have a numerator and I have a denominator in a ratio, and if that ratio is always the same number, in this case 0.78527 or 0.7853, basically the same number, then we say that the numerator and the denominator are proportional. That's what we mean by proportional. In this case, we not only have a proportionality, but we have a power, because the squaring something is raising it to the second power. So the area is proportional to a power of diameter. Now, what does this mean in terms of formulas? We're going to let A of D equal to the area of pizza with diameter D. Okay. Then A of D divided by D squared, we've already seen that's always equal to about 0.7853. So that means that A of D is equal to 0.7853 times D squared. So this is an example, our first example, of a power function. Area is a power. What is a power function in general? It's a function that looks like this. F of x is equal to some constant, the constant of proportionality, times x squared. In our case, x is our diameter d, and our constant k is 0.7853. But this is the general formula. This is what it looks like in general. And you've seen these functions before. This is just a quadratic, and then k is a constant. We could actually graph this function. You've probably done this before. The graph of a quadratic looks like this, where how fast you increase depends on k. If k is large, then it looks more like this, and if k is small, it looks more like, more like this. Okay, so that's an example of power function and constant proportionality k.